Hi there, this is Chapter 7, Base E and Natural Logs. This is actually should be pretty short and pretty simple. So here we're going to evaluate expressions involving the natural log of base and the natural logarithms. We're going to solve exponential equations and inequalities using natural logs. So let's just get right into it. What is natural base? So basically, natural base E is a value. Compare it to pi. Like pi, we think sometimes is a variable, but it's not. It has a value of 3.14. Well, E is also an irrational number that has a value of 2.718, and it goes on forever. Okay, so it's just a number. So that's what a natural base is. What is a natural base exponential function? Exactly what it says. It's an exponential function. Oops. Right, so with the base E. That's what it is. It's just an exponential function, a function with the base E instead of 3 or 1/3. All right, and what's a natural logarithm? Natural logarithm, which we'll learn, are inverses of the natural base exponential. So just like we had y equals b to the x as the exponential functions, and we said their inverses were log y equals log base b of x. We've got the same thing going on here, except for we use ln as our word for natural log. So we'll come back to that. So let's look at the key concept box and understand this a little better. So these two are inverses of each other, just like these two. So we just have another group. Patterns are really similar. You'll see and notice a lot of the characteristics. You just got to know that each is just a number. 2.71, we're going to use 2.718 as our, instead of 3.14 like pi, E has its value. All right, so look at the key concept box. It says the function f of x equals e to the x is used to model continuous, this is important, continuous exponential growth. And the function f of x equal e to the negative x is used to model continuous exponential decay. So here are the graphs. So you see the two blues are the natural base functions, exponential functions. So instead of using 3 points, we only use 2 points, and the points are 1, e, which is 2.718, and 0, 1. And then the decay, so do you notice that the x is negative? And it's the same points, except for we have -1, e, and 0, 1. So it's slightly different. So know that those points, that's where it differs from exponential. Remember, the 3 points were the exact same for growth and decay. Here, they're slightly different because your x is negative. Now, you see the line y equals x, they reflect, and they show us the natural logarithm, which we said are inverses to the natural base exponential function. We call them natural base because we're saying e is a natural, we call it a natural base number. It's e. That's all it means, is exponential function with the base of e, which has a value of 2.71. And you see how the graphs, the growth does this, and it uses 1, 0, e, 1 because they're inverses of each other. And this is going to be 1, 0, e, -1. The functions are f of x equal natural log. So we represent natural log with the letters ln. And then if we have y equal e to the negative x, its inverse is going to be negative natural log of x. So this you do have to learn, memorize. It's slightly different. It's not going to be on the current test. All right, so let's start example 1. It says write each exponential equation in logarithm form. So let's do that. It's not any different. So we have e to the x equal 8. So remember, I said put your exponent should go on the right and your log should go on the left. So what are we going to do? This becomes the base. We say natural log of 8 equal x. Now, they don't really tell you this in the book, but because I have the ln, that represents natural log instead of just regular log, and it implies a base of e. So you don't ever have to write this e. That would be redundant. So you would just write this as the natural log of 8 equal x. And it's implied your base is e. So make sure you know this, not in the text. Let's do x equal e to the 5th. Again, it just comes down. So you just add the word natural log of x equal 5. All right, do the guided practice. And let's look at example 2. Now we want to do the opposite. They want us to write each logarithm equation into exponential form. So again, natural log of x is approximately 0.7741. So how would we do this one? Again, what is our base? Our base is an implied e, and you just raise it up. Pretty simple. What about 1b? So again, we have e to the 7th equal x. Oh, no, that's guided practice, sorry. Natural log of 10 equal x. Again, my base is e, so you say 10 equals e to the x. Pretty simple. You're just going from exponential form, or from logarithm or natural log to exponential, and you can do it back and go backwards. All right, let's look at example 3. This is simplified. Just like logs, all the properties apply to natural log. The only difference is your base is e, which makes it much, much simpler. You'll see in a minute. So we can make this to one simplified log, or natural log. So again, we have times here, right? This is one term and this is one term. Well, I can use the power of power rules, right? And undo it. So it's natural log of 10 to the 3rd power. So my argument's 10 minus natural log of 8. Now, I have the same base. Doesn't matter if there's natural log or log. So I can make it as 1. So I can say the natural log of 10 cubed divided by 8. Now, what you have to know is, and I'm going to go ahead and write this, that 10 is 2 times 5 times 2 times 5 times 2 times 5. This is what 10 cubed is. And 8 is 10, 2, 2, 2. Now, this cancels, that cancels, this cancels, this cancels. So what am I left with? I'm left with the natural log of 5 cubed, right? I have 3 5s left. And then I can change this to 3 natural log of 5 using the power of power rules. So here I use the power of power rule to change it to this step. Then I use the quotient rule of logs. Then I just use simplifying, simple math, put it back in exponential form, and then I use the power rule to get one final step. All right, so that would be your answer. Let's look at B. So we have the natural log of 40, but you've got to know these properties. If you don't know the properties, then you're not going to, you're going to struggle with this. So I can't do anything here, right? So first of all, let's identify all our arguments. Let me put a different color. These are our arguments, yes? And this is one term, one term, one term. Well, I have time, so I can use the power rule. So this becomes, and I can change this 2 to the negative 1. So I have the natural log of 2 to the negative 1 raised to the 2nd power plus natural log of x plus the natural log of 40. Now, they're all natural logs. They all have the same base, so I can combine them to 1, which is the product rule. So I have the natural log of 40 times, okay, this is 2 to the negative 2 times x. Then 40, you should know, is 2 times 2 times 10. So, and I'm just using simple math. This is simple exponential forms, right? This all means multiplication. So what do I know? 2 squared times 2 to the negative, I have exponent rules, just basic. It's 2 minus 2, which is 0, which is 1, so I'm left with the natural log of 10x. That's your answer. But you got to know that this simplifies. If you leave this an answer like this, it will be wrong or I will take points off. This would be the final answer. All right, do the guided practice 3A and 3B. Let's look at example 4. It says solve base E. So again, what makes this much simpler is when you take the natural log of E, it's going to equal 1. Because remember, your base is E. This is your argument. So know the difference. This implies base E. When you have the natural log of E, it just equals 1. Okay? Just like the log base 10 of 10 equals 1 as well. Okay? So just like we could solve by taking the logs of both sides, we could take the natural logs of both sides if we wanted to. So let's start with this equation. We have 4e to the negative 2x minus 5 equals 3. So the first thing you do, I'm going to add 5 to both sides. So I have 4e to the negative 2x equal 8. I'm going to divide by 4. E to the negative 2x equal 2. I'm going to rewrite this to say 2 equal e to the negative 2x. Now I'm going to change it from exponential form to natural log form. So natural log of 2, right, I don't have to write that e, it's implied, equals negative 2x. Oh, sorry, I lied. I'm going to take the natural log of both sides. So I'm going to have the natural log of 2 equals the natural log of e to the negative 2x. We said this is implied base e, so this equals 1, so this just becomes the natural log of 2 equals negative 2x. So this is 1. Remember, I can use the power of power rules. If you're confused how I did this, I could rewrite this. I'm going to write over here to show you, to say negative 2x times the natural log of e, and we said the natural log of e equals 1, and 1 times negative 2x. So that's how we get this. Now I need to divide by negative 2. So x is approximately negative 0.3466. And you put it in your calculator, you hit, there's an ln button, which means natural log. So you would hit ln 2 divided by negative 2, and you would get this answer. All right, do guided practice 4A and 4B. Let's look at example 5. They want us to solve each equation and equality. Same rules apply as if we had regular logarithms. Okay, so I'm going to divide by 3. So natural log of 4x equal 8, correct? Then I'm going to change this to exponential form. 4x equal e to the 8 because e's a number. And then divide by 4 and divide by 4. So you plug this into your calculator. You hit second natural log button, and then it'll let you put the 8 in for the exponent, which x is approximately 745.2395. All right, let's look at B. It's an inequality. So we have the natural log of x minus 8 to the 4th less than 4. So what am I going to do? First of all, I'm going to change it to exponential form. So if x minus 8 to the 4th power is less than e to the 4th power. All right, so I take the 4th root of both sides, right, because I've got 4 of them, so I can get rid of this parentheses, less than, right, to e, because it's e to the 4th power. So then I plus 8. Now it's just using simple math, less than e plus 8, and you put that in your calculator. Remember, this is implied e the first. So it's x is less than 10.7183. Why do we not have to worry about negative numbers? Because we have a less than sign. Because we're going to, this is raised to the 4th power. It's an even root, even power. So even if it's negative, it would become positive. So I'll never have a negative argument here. So it doesn't matter what x is. All right, let's look at one last thing. And why we use this is because we use it for finances and what they call continuously compounded interest. We've already learned what compounded interest is. Now we're going to work with continuously compounded interest. And that formula is going to be A equals P times e to the RT. Okay, so P is your principal amount, the amount you invest, the amount you started with. R is your interest rate, and T is the time in years. And A is the amount that you have in the account after 2 years. So let's look at the example 6. It says Angelina was born. When she was born, her grandparents deposited $3,000 into a college savings account, paying 4% interest compounded continuously. The key word is continuous. Assuming there are no deposits or withdrawal in the account, what will the balance be after 10 years? You're going to use this formula. So our principal amount, they want to know what the amount is. Our principal is $3,000. E, our interest rate, 0.04, right? And the time is 10 years. So you can put this in your calculator, e to the 0.4 times 3,000, and you're going to get $4,475.47. All right, let's look at B. How long will it take her balance to reach 10,000? So now we want A to be 10,000. We know our principal. E, we know our interest rate, but we want to know how long. So again, this is just solving an exponential equation. So I divide by 3,000, so I get 10 over 3 equals e to the 0.04t. Yes? So then what are you going to do? You're going to change it to, you're going to take the natural log of both sides, right? So natural log of this, natural log of that. When you take the natural log of the right side, you end up with 0.04t equals the natural log of 10 over 3. Remember, that's the whole thing is your argument, not your base. And then you just divide by 0.04, and you get t is approximately 30 years. All right, let's look at C. It says if her grandparents want Angelina to have 10,000 after 18 years, so the amount is 10,000. After 18 years, so e to the 0.04, 18 is going to go here. They want to know how much should they invest now. So what should the principal amount be? So again, this is a number. So we're just going to divide by, this one is pretty simple, 0.04 times 18, and you're going to do the same thing here, e to the 0.04 times 18 to get P. You put in your calculator and you get approximately $4,867.52. All right, let's stop the video, do the guided practice, and we'll see you in class.